Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem in which we have to find out the solution of differential equation this. So, look at this. How does it look like? So, I feel that like first we have to solve this differential equation. This is the first idea. Now, I will be trying to apply the first filter, that is variable separable method. Now, like if I will give a glance to this question, I don't think that I can separate these variables independently. Means we cannot put all x together, we cannot put all y together. Okay, so what I should go with, like we have to go with next filter, but before solving that I will apply the first filter of variable separable method. Okay, the idea is, like if dy by dx equals to linear, then we have to take that linear thing as z, but here we don't have dy by dx equals to linear, so that idea won't work, I feel so. Then we have dy by dx equals to linear by linear. Okay, and that too the coefficient of middle element means y and the coefficient of x from the denominator sum up to 0, then only you can apply second filter of variable separable method, which is not available here. We should have dy by dx equals to linear by linear, so that filter also fails. Later we have polar form. In polar form, if we will find x dx plus or minus y dy, then we will apply that idea, correct now? So look at this. So if we will observe x dx plus or minus y dy, then we can apply this idea of polar form. Okay, so look at this. Can I take LCM dx? So we will have what? Solution x dx plus y dy, and then we have x dy minus y dx, and dx gone. So look at this, you have x dx plus or minus y dy, correct? Now look at this, how I will respond. You know that if we will have x dx plus y dy, then we will be using sine and cos, correct? And for sine and cos we have extracted one information, that x dx plus y dy will produce r dr, and later we have calculated x dy minus y dx equals r square d theta. Hope you remember this thing. Now we will apply this substitution over here. Now the idea is x dx plus y dy is what? R dr. Then we have x dy minus y dx, that is r square d theta, correct? Now we will replace this x square plus y square as well. Now you know that x we used to take as r cos theta plus y as r sin theta, है ना? So x square plus y square will become what? R square. So 1 minus r square, and then we have denominator as only r square. I hope till this part you guys are okay. Now look at this. If you try to simplify things, r 1 r gone. Here you have 1 r, and because of the square root we will have 1 r. So this thing gone. So we are left with dx, wait, it is dr, okay, that is d theta. No, wait, it was correct, d theta only. Yes, d theta. Here we have dr, no? Acha, by mistake I have introduced x again, so this is dr. Okay, so we will keep r thing one side, 1 minus r square is equal to d theta. Okay, now what we have to do, we have to simplify this differential equation by taking integration both side. Now if you will try to recognize this dx by 1 minus x square integration, its integration is sine inverse x. So can I write here sine inverse r, in place of x we have r, and integration of theta is what? One is what? Theta plus c. Now who is r? So r, you know that, like we have x square plus y square equals to r square. We have to convert everything into one thing, and also y by x we have taken as tan theta, है ना? So we will take in place of r, can I write sine inverse root over x square plus y square. Now we have already converted our LHS component into x and y. Now in place of theta, can I write tan inverse y by x plus integration constant c. Okay, I hope the idea is clear and you guys can handle similar situation. So see you guys in next session of MathFlix.